So today's objective, we're still continuing with I can solve real world problems using linear equations. We know what linear equations are, so we don't need a Freire model. Bless you. Yes. We also know the process we've been using for problem-solving strategies. Yes. So we did examples 1, 2. We did some with the airplanes. Remember that? Okay. Then we went and we did some with. We didn't do this one. Yeah, we did. Yeah. Yeah, we did. Yeah, we did. So, anyways, and then on your on the play sheet, you had something that was related to the rate, but it was in regards to water and streams and stuff like that. But the process is the same. So if you're going uphill, does that increase your speed or does it decrease your speed? And it works the same here with upstream and downstream. That's what it's talking about in regards to you understanding the increasing and decreasing of the rate. Okay? But I want us to get to this one right here. Copy this one, please. Example number 6. It says, a chemist mixes a 20% saline solution and a 40% saline solution to get 60 milliliters of a 25% saline solution. How many milliliters of each saline solution should the chemist use in the mixture? Copy that, please, and then we'll go over it together. Okay, can you read that for us again, please, Sergio? I can't hear. Guys, I can't hear. All right, so like with the other systems, let's get a table going. 3 lines down, 1, 2, 3, 2 across. Whoa, that's kind of crooked. All right. Now let's go through, see what kind of information is the first thing that you see that's so obvious. The percentages. Who sees that this is different from the other problems that we've done, right? Percent, and percent. Do we use decimal or percent? Well, that's where I'm going. Good question. Did everybody hear the question? Do we use decimal or percent? Well, let's see. Here they give us percent, but what is this one? It's a number, but it has a decimal. Therefore, these are percents and these are decimals. So we're going to be converting, because look at the question at the end. How many milliliters? Here they give us the milliliters and decimals, and that's what we're going to be converting to. So that's the process. So let's see. Mixes. So the mixes is 20% saline solution, 40% saline solution. To get, what does to get mean? Equal or total. 60 milliliters of 25% saline solution. Okay, so here we see 2 different things. So the setup is similar to what we've done in the past, but let's identify the mixes. A chemist mixes 20% saline solution. So we're going to label this one a little 1 right there, because that's our first mixture. And a 40% saline solution. So this is our number 2. To get, what does that mean? Equal to what? All this, which is the total. Does that make sense? The 60 milliliters of 25% saline solution. So we're going to label this first mix. Leave a little space here because we're going to write something else there. Second mix. And here, total mix. Boss, I don't see you writing. My goodness. So what's the percent for the first mix? 20%. That goes here. Second mix is 40%. That goes here. And the total mix is 25%, which is down here. Are we there so far? Yeah. Okay. So now to start organizing our information, like we said, we no longer are going to be using percentages, so we need to convert percent into decimals. So how can we write 20% as a decimal? Point 20. 0.2 or 0.20? I'm going to write 0.20 just so you can transfer the same. Question here. Let's read it again. It says, a chemist mixes 20% saline solution. Does it say how many milliliters it used? No. So if we don't know, what can we label this one? X. Very good. Next one, 0.40. And let's read the second part. And a 40% saline solution. Does it say how many milliliters? No. So that one we're going to label Y. Okay. Now check this out. Before we write the last one. Everybody understands now, by now, hopefully, we're at the semester, that whenever you have the variable and the coefficient, what operation is in between? Multiplication. The only thing here, instead of a number, we have a variable, right? Okay, let's go to the total. The total, it says 25%, that's 0.25. Does it say how many milliliters? Yes, how many? And what do I do? Parentheses, 60. Well, here we don't use a variable because we know how many milliliters it is. So how much is 60 times 0.25? 15. That goes right there. Thank you. Are we there? All right. So now that we have the percentage and we converted them into decimals, now we're going to the second row. This one is the item type. What kind of items are we talking about? Saline solution. And here we're talking about milliliters. Item. So clear. Okay, let me rewrite this. Item, saline, solution. Are you laughing at me? No. Be nice. Yes. All right. Yeah, so item type is saline solution, right? So how many milliliters was the first mixture? X. How many milliliters for the second? And how many milliliters for the total? 60. Hold on. ml, milliliters. Okay. So, focus, please. Do you guys see now the system forming? Okay, write out your system. See if you got it. Okay, so it's 0.20x plus 0.40y equals 15. And then it's x plus y equals 60. Question here, which variable would you like to eliminate? X. Y. Okay, so let's eliminate x. So that means to eliminate x, we need to multiply times negative 0.20, negative 0.20, distribute. This becomes negative 0.20x, negative 0.20y equals negative 12. Now we can eliminate, right? 20 minus 20, it cancels. 0.40 minus 0.20, that's 0.20y equals 15 minus 12, that's 3. Divide by 0.20, divide by 0.20. Y equals, let's see, 3 divided by 0.20. Move the decimal twice, 2 zeros. Fits in there, no more decimal, fits in there once. 15. 15 what? Tell your neighbor, please. Milliliters. 15 milliliters. So let's use our item type of equation, x plus y equals 60. But now we have a value for y, so it says x plus 15 equals 60 minus 15. X equals 45 what? Milliliters. Now keep your percentages and your milliliters organized, because this is in order for you to write your answer, which it has to be in a sentence form, you need to match up the milliliters that correspond to the percentage mixture. Yes. Okay. Okay, Santi's saying that why don't we write the 45 ml right here and 15 ml right there, and then that'll help us focus for the sentence. Very good. Damn, Santi in the house. All right, let's write our sentence. Here we go. The chemist mixed. Okay, help me out. What do I write? Because it says how many milliliters of each saline solution should the chemist use in this mixture. So what's next? The chemist mixed 45 milliliters. Yeah, aren't we starting with X? 45 milliliters of 20% saline solution. Yeah, that was the whole conversation. I said, make sure you match the milliliters with the percentage. The chemist mixed 45 milliliters of 20% saline solution with what? 15 milliliters of 40% saline solution. Wow. Solution for a total of 60 milliliters of 25% saline solution. Mr. Q, what does it say after 15? 10Q. 15 milliliters of 40%. Okay? All right, so here goes the process again. We build our table, we underline and circle the important information. And here we write mix 1, mix 2 in total with percents. We change percents to decimals for the second row. Third row is going to find the milliliters, which is the answer that, to answer the question that they're asking. So therefore, for milliliters, we do the last row. From there, you build your system, and you solve. Now, question, to think a little bit outside the box. Let me get your noodle going. So focus on the screen. Let's say you are here. Here's your system. Look up, please. 0.20x plus 0.40y equals 15, and x plus y equals 60. And I wanted to eliminate x. What's another way, or by what other number can I multiply one of the two equations to eliminate x? Think about it. Some of you already saw it. I'll give you some time to discuss it with your neighbors. How can we multiply one of the two equations times another number to eliminate x? Right now we're eliminating x. Talk it over with your neighbor, please. Okay, here we go. We have 0.20x plus 0.40y equals 15. And we have x plus y equals 60. What can we do? Patrick. Multiply the bottom one. 1 over 5. Well, it's the same thing as that, right? Okay. Yeah, I'll take that. What other way? Seabass. Let's see. Multiply the top one times -5. Why -5? Because this is 0.20. What is 0.20 times 5? This is 1. This is going to become -1. I said any equation times a number to eliminate x. So let's see. This becomes -1x, -2y equals negative, what is that, 75? Now we can eliminate these two. Does everybody see what we're doing? We end up with -y equals -15. Divide by -1. Y equals 15. Yes? Just FYI. Okay? So, that's mixture problems. Look at this next one. Look up, please. Example 7. Don't copy this, but get a table ready, please. Get a table ready. It says, suppose a pharmacist wants to get 30 grams of an ointment that is 10% zinc oxide by mixing an ointment that is 9% zinc oxide with an ointment that is 15% zinc oxide. How many grams of each ointment should the pharmacist mix together? So, I'm going to underline important stuff, and I want you to set up your table and see if you got it right. I'm going to give you some time to do that. Here we go. So, important information here, I see the percentages. I see grams. I see zinc oxide. And the question they wanted in grams. Okay? Set up your table, and then I'll set up mine and see if it matches yours. Go. All right, here we go. 3 lines down. 1, 2, 3. 2 across. So let's see. It says, suppose a pharmacy wants to get 30 grams of an ointment that is 10% zinc oxide by mixing 9% zinc oxide with 15%. So we still have 2 mixes. First mix, second mix. And here, total mix. All right. So the first mix, let's see. Let me read it again. Suppose the pharmacist wants to get 30 grams of ointment that is 10% zinc oxide by mixing the ointment that is 9%, so 9% goes here, 15% goes here, and the total is 10%. Here it goes again. Look up. If you put this one over here, that's fine, as long as the mixes are here and the total is over here. Okay? So, why is it in this order? Because you need to look for where it says by mixing, and then it tells you which are the mixes. So by mixing, what is he going to mix? This and this. He wants to get, yeah. So here we go. Here is percents into decimal. Therefore, this is 0.09x, 0.15y, 0.10 times what? 30. And this gives us what? 3. Right here we got item, and that is zinc oxide, and it's in what? Grams. It's in grams, no more in milliliters. Therefore, this is X, Y, and 30. So my system, let's see, 0.09x plus 0.15y equals 3, and X plus Y equals 30. Hands if you got that by yourself. Okay, good. So what did we go over right now, this one, so that you can read it and make sure you understand which ones are the mixes. Sometimes they're going to say it at the beginning, sometimes they're going to say it at the end, so be careful with that. What's that? Yes. So don't solve it. This is I just wanted to make sure that you got the setup. Let's move on to the other type. This is the last kind of word problem that we're going to look at, which is the digit numbers. Here we go. Example 8. The sum of the digits of a 2-digit number is 10. When the digits are reversed, the new number is 54 more than the original. What is the original number? Copy that, please. Oh. 3 lines down. 1, 2, 3. 2 across. So let's see what kind of information they give us here. The sum, that's important, of the digits, that's important, of a 2-digit number is 10. Okay? When the digits are reversed, the new number, that's important, new number, is 54 more than the original. Okay? So what are we doing here with? We're dealing with the original number, and this is the new number. So let's label this original number, and this one will be new number. Pay attention, please. So since we're dealing with 2 digits, what placement do we have in those 2 digits? If we're dealing with 2 digits, what is the placement that we're dealing with? Very good. Tens and ones, which is units, and the total. Do we know the original number? No. So therefore, for tens, we're going to label this one T. For units, we're going to label it U. And the total should be what? 10. Hold on. Let me just help you set this up. Let's reverse these. So now this one's going to be what? U. But so that we know that it's in the tens place, what do we label it? 10U. This one is T. And then it says 54 more than the original. So the original was T plus U plus 54, but to make it in the terms that this one has the 10 here, we're going to put 10 here also, like this. Okay, watch. Look at the system now. We got T plus U equals 10, and I have 10U plus T equals 10T plus U plus 54. Now, before you leave, let me just show you how to set up the system to solve. Don't we need to get all variables to one side? Yeah, so here I subtract 10T, and I subtract U from this side. So, and whatever I do to one side, I do to the other. Subtract U and subtract 10T. Everybody see what I did? Yeah. We got 9U minus 9T equals 54. Are we there so far? Yeah. And then I bring this one down over here. So, and I'm going to write it in this order. I write the U first, plus T equals 10. Do you know how to solve this system? Yeah. So home plate for tonight is play sheet 6-4, and you have it already on the reverse side of the other, right? Good one, guys. There's student today. If I don't see you guys tomorrow. Bye.